Okay. Can you see my screen?
Yes, we can see the screen.
Wonderful. Let me just arrange everything, the chat and stuff. Okay. So, as I said, okay, let me start with that. This is a very small graph of who I am. I always like putting this in the first slide. We will not create a such graph because it seems very complex, I think. Anyway, this is my website in Academia Edu. My name is Rafail Giannadakis. I am a student, a BA student of Classical Studies in the Department of Philology of the University of Crete, which belongs to the Department of Philology, which belongs to the University of Crete. I am also a research assistant of TALOS-AII for SSH, the ERA-Chair European project, and I'm also a contributor to its dissemination activities concerning research and social media. Okay, let me go on. I stole this slide from Mariette. I like it so much. In the first part of this training, I will introduce and I will summarize what Maria said concerning ontologies, knowledge graphs, RDF graphs. I will introduce you to the theories of concept and the distinction between conceptual and linguistic dimension, which is very interesting. And also it will be, I think, very interesting for all of you because as I understood, we have linguists in our small group, so this will be very interesting. And in the second part, we will create altogether an Ontoterminology focused on modeling biographical knowledge about 4 ancient Greek and Chinese philosophers, which is more or less what we are trying to do in this ontology and ontoterminology we are building for the Kelkip project that Maria presented you more or less in the previous session. Let me start with what is knowledge modeling, and a knowledge base. Knowledge, according to the Oxford Dictionary of English, it's facts, information, and skills acquired through experience or education, the theoretical or practical understanding of a subject. And secondly, awareness or familiarity gained by experience of a fact or situation. This is a very interesting definition of knowledge. So knowledge is very, very linked with what we have experienced, what we know practically or theoretically. And since we are always, we are in a university, so we are in academia, so we always care about the knowledge. Today, what we will be doing is knowledge modeling, which of course is linked to knowledge. But what is knowledge modeling? Knowledge modeling, I like this definition, deals with the representation of knowledge in a form that can be interpreted by both humans and machines, and it is used in knowledge-based systems. It is a sub-area of knowledge management and artificial intelligence. So knowledge modeling belongs to the huge artificial intelligence, let's say, field. And what we are trying to do is to represent this knowledge in a way that can be understandable by both humans and machines. Okay, we have the knowledge, we know what we know as humans, but computers do not understand what we know. And what we are trying to do in knowledge modeling is trying to represent everything in a way that also computers can understand what we know, or in the best way we can help them understand what they know, what we know, okay? So this is more or less what we are trying to do. We have the knowledge, the theoretical or the practical knowledge that we have gained through our daily life, through our studies, through our studying, etc. And now we are trying this knowledge to represent it in a way that can be interpreted by both us and machines. And I keep saying by both us and machines, because, okay, we will create these knowledge bases for computers to understand what we know, but we still want humans to understand what we are representing and what we are building. This is very important. I don't want to create, at least, I don't want to create knowledge bases that they will help only the system to understand what I want to model. I want to create knowledge bases that can be helpful for the people of my field. I create a knowledge base, and I want this knowledge base to also be readable and understandable also from humans, so they can use it for their own purposes. Okay, and this is very important, I think. And lastly, a knowledge base is a collection of interlinked descriptions of entities, real-world objects, events, situations, or concepts that enables storage, analysis, and reuse of this knowledge in a machine interoperable way. As a result, it empowers search engines and other content retrieval applications to interpret text and match it to advanced queries. So this is what more or less me and Maria are trying to describe these days. We have our knowledge, we want to model this knowledge so we can be understandable by both humans and computers and computer system, and this knowledge modeling enables the storage and analysis and reuse of the knowledge modeled. Okay, so as a result, it empowers search engines and other content retrieval applications to interpret text and match it into advanced queries. Okay. So this is, I like this slide very much. We can read it in many different ways. The way I want to present it to you today is in a way you will see in the bottom level, the data level. So as Maria told you in the previous session, we have a web full of documents, full of URIs, full of images, full of everything. Okay, and this is our world. This is our digitally enabled world today. Okay, we have composed of diverse and complex systems. And I think, and of course, I'm not the only one who thinks that today, the next major evolution is to connect and represent information with semantics in the web. So in this way, even the computer can understand why we represent these things, why they're there, what is the meaning behind, what is the connection behind these things, okay? And in this way, the knowledge, as I already said, it can be understandable by both humans and machines. Okay, so this allows data, as you can see in the metadata level and in the ontology level here, this allows data to be linked and understood, enabling computers to interpret and reason about information. Okay, so this more or less links to greater interoperability, more precise querying, and the development of intelligent automated applications. Okay, and I have also put this photo, this Ontotext photo, which is very interesting, and it is more, I think, you can see here the global knowledge, all the knowledge that we have in the web, and how the semantic layer puts everything in order. And this is not just a picture, this is completely true. This is what semantics do. Okay, puts everything in order. These knowledge bases are not just for us to prepare a knowledge base. These are very useful because we put meaning on what we want to have in the web. We just don't upload stuff in the web and leave them like that, like upload documents and documents and documents. Now we put semantics, and this is very interesting and very, 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 very important. So in more or less ontologies and semantics are vital in a web filled with these documents, URLs and URIs. And what we do and what they do, ontologies do, they provide a more structured framework that machines can process, resulting, as I have already said, in more meaningful, if we can say, data connections and improved information retrieval. You saw that with the SPARQL. I retrieve what I want to retrieve and what very specifically want to retrieve. And this is very interesting in my opinion. As you have understood, and I think this is okay, this is very tiring in a way. I always say that I don't want to create this knowledge bases just for the web. The web is there for us, for our use. And as I have already said in the previous session, I am very interested on how these tools that we create can be utilized by traditional scholars. In my field, because I'm a classicist, by classicists. What classicists can do with the utilization of these tools, okay? So let me start with the knowledge bases, with the different knowledge bases. Here is a picture of the lacrimal ontology that Maria Papadopoulou and Christophe Ross have created in the context of a Greek project in the Ainsforth. And what is an ontology according to the Oxford Dictionary of English? Firstly, it mentions the branch of metaphysics dealing with the nature of being. Okay, we have ontology, ontos και logos, which is defined by Aristotle. Aristotle is an ancient Greek philosopher. We will see more things about him later because we will try to model Aristotle. And secondly is a set of concepts and categories in a subject area or domain that shows their properties and the relationships between them. This is not the best let's say, definition of what an ontology is in a computer science or artificial intelligence, but it's a very good definition. So we have the concepts, we have the categories in a very specific domain of knowledge, and we have also their properties and the relationships between them. So we have our knowledge, and we turn this knowledge into concepts and categories in our, which these are linked to our domain of interest, and we try to see the relationships between them. So we define everything in our ontology, and this is how we have this knowledge base. Here is the definition of the ontology from the practical guide to building our ontologies using Protégé. Ontologies are used to capture knowledge about some domain of interest. So we have already seen that. An ontology describes the concepts in the domain and also the relationships that hold between those concepts. Different ontology languages provide different facilities. And I think that you may have understood that I put this, definition for the last sentence. Different ontology languages provide different facilities. So we have, you can already see that languages are very important in our field. And this is a very easy graph. I retrieved it visualizing an ontology. You can see that here. So you can see how we build an ontology very easily. This is not an ontology. Of course, it's a first graph, but okay. So we have triples, okay? We have nodes and links, okay? So we have a person and a car. What's the relationship between a person and a car? The person owns a car, and the car, we have the inverse property, is owned by the person, okay? The person works at a company The company has worker, the person, and the person uses an umbrella, and the umbrella is used by the person. So, and Maria has very excellently described this thing. We have nodes, okay? And we have the relationships between these two nodes. It is very important to understand that the properties, that the relationships between the objects are defined by the domain and the range. So we have the person, the domain node that owns a car, and this car is owned by the person. So this is the inverse property. Here we have, if we have the person as a subject, the person owns a car. If we have the car as an initiative node, the car is owned by the person, okay? And this is the last definition for the ontology defined by Christoph Roche. And he has also put the Chinese translation, so this helped me a lot. For you. An ontology is a shared description of concepts and relationships of domain expressed in a formal and computer-readable language. So in my opinion, and not because Christoph is my professor, let's say, but this is the most complete definition, a very short definition. So Christoph has put everything. It's a shared description of concepts and relationships. So we have our knowledge, and we based on our knowledge, we create concepts and relationships of our domain. So we have the concepts and relationships based on our knowledge of our domain of interest in a formal and computer readable language. We have to understand that computers do not understand a thing. We have to define everything. Okay, and if we understand something, I think this is very easy to get it. If you understand something, does not mean that this thing is understandable by the computers. Okay, so let's move on to the knowledge graph. What's a knowledge graph? A knowledge graph is a directed labeled graph in which domain-specific meanings are associated with nodes and edges. A node could represent any real-world entity, for example, people, companies, and computers. So what we have until here, we have a graph, a knowledge graph, which in this graph, everything is, the nodes and the links are directed and labeled. So we have meaning. Meaning is very important. And this meaning, these links, they connect nodes and edges. And as Maria have already said, a node could represent everything, anything. For example, people, companies, and computers. An edge label captures the relationship of interest between the two nodes. For example, a friendship relationship between two people, a customer relationship between a company and person, or a network connection between two computers. So as you can understand, we can create a knowledge graph and represent anything. So let's see that in a more, let's say, visualized way. So we have two nodes. We have a subject and we have an object. The subject is the initiative node. It is the domain node. It's the starting point. And we have an object, which is the range node. And these things are linked with something that we call predicate. Sorry, I have put predicate twice here. Relation or relationship, okay, or link. So there's so many things that you can call it like that. So this is the way that we can put it in its place. So if we have, for example, Aristotle has written metaphysics. Aristotle here is the domain node, and metaphysics is the range node. So Aristotle has written metaphysics. Can any of you sorry, let me see the chat too here. Can any of you help me how we would define the relationship has written, its inverse relationship, so we can have metaphysics as a domain node? So if we had, okay, let me laser, okay. If we had metaphysics here as a domain node and Aristotle on the other side, how we would say that how we would define the property? Can anyone help me with that? We have Aristotle has written metaphysics. If it was metaphysics, Aristotle, how we would define the property? Wonderful, wonderful, Maggie. Metaphysics is written by Aristotle. So this is the inverse property. Metaphysics is written by Aristotle. So now we can start and understand, understanding that these properties can have some characteristics. So the first characteristic that these properties can have is the inverse property. So Aristotle has written metaphysics, but here Aristotle is the domain node. But what if we have metaphysics as the domain node? Metaphysics is written by Aristotle. Okay. Don't be scared. It's a full slide. I hate full slides. Full of text. This slide is taken from, and all these pieces of information are taken from the Protégé documentation. Not everything of these characteristics of properties are used in the TEDI tool that we will use. But I put everything here so you can start having an idea and to start thinking differently. Because when you start building such ontology, you have to start thinking differently. And this is very important. So let's start seeing one by one. So functional. The functional characteristic of a property asserts that the selected property is functional, and this means that for any given individual, the property can have at most one value. So we have a node that it can be linked for a property only with one value. So this is an example. Confucius, born in, sorry for my horrible Chinese, to this location. Khufu, I don't know. I'm so sorry for my awful Chinese. So as you can understand, when we when we have the born-in relationship, because a human being can, or a being generally, can be born only in one place. I cannot be born in different places because I'm only born once. This is an example of a functional property, okay? And that is why these things are not put in the PowerPoint that I sent to Luisa. That is why I have sent in the chat my slides again from the first session. So you can have it from there because these examples are not in the PowerPoint that I sent to Lisa. Then we have the inverse functional. So the inverse functional is a little bit more complicated. So we have let's say we have Confucius has written analects. Okay, analects were not written by Confucius, but okay, let's say for today that they were. So Confucius has written Analects, okay? So if we say that Confucius has written many philosophical works, we cannot say that it's a functional property, okay? Because Confucius has not only written Analects, but if you think about it, Analects were written only by Confucius. So this is an example of an inverse functional property. Previously, we had Aristotle has written metaphysics, but Aristotle has not only written metaphysics, right? But its inverse property, it's functional because metaphysics were written only by Aristotle. Okay? Is this fine by here? Are there any questions by here so far? Don't hesitate to interrupt me, really. I can speak non-stop for many hours. So then we have the transitive. The transitive means that if an individual X is related to an individual Y, and individual Y is related to individual Z, then individual X will be related to individual Z. So this is very interesting, for example, with family descriptions. So if I have Sophia is parent of Nikos and Nikos is parent of Rafail, Sophia and Rafael are related as Sophia is the grandmother of Rafael. And we can say that if we say in the parent of relationship that it is transitive. Then we have the symmetric property. The symmetric property means that the property has itself as an inverse. So if individual X is related to individual Y, then individual Y must also be related to individual X along the same property. And a very good example of this characteristic is with the friendship relation. So if we say that Maria has friend Rafael, Rafael has also friend Maria. Okay? So, and this is the symmetric relationship. And then we have the asymmetric relationship, which is Maria is manager of Rafael. And because this is a hierarchy, we cannot say the inverse with the same relationship. Okay? And lastly, we have the last two, the reflexive, which is, and I stole this from the lacrimal ontology, an event has caused an event. So we have asserting that the property is reflexive causes every single individual to be related to itself via that property. But as you can understand, this thing cannot happen with relationships such as is older. I cannot be older than myself. Okay, and this is an example of an irreflexive property. Okay, so are there any questions? With, of course, these are not that useful for today. I just wanted a little bit to change your way of thinking and start thinking in many different and parallel levels, because this is what you will need when you will build your own ontologies. Okay. Maria, sorry, I just saw why go into all this trouble to be interested in the properties of relations. Sorry, Maria, can you explain this more? Because
yes, properties such as reflexivity, symmetry, antisymmetry, transitivity. Why do we need these relations to define? What is the use of properties of these relations? Why? Why? It would be useful to explain why go into all this.
Yeah, this is very important for the system. The system needs to understand what we are building and why. Because of course, if you can understand that if we just put relationships in a system and try to define only the domain and the range, this will not be that useful for us. We need to define our characteristics of our relationships so the system can understand what we want to do. So if we say Maria has friend Rafael, okay, do these properties go over all types of relations? That's a very interesting question. It depends. For example, Protégé has all these characteristics. TEDI does not have all these characteristics, and we will see that later. In my opinion, and in the ontology, in the basis that I have created, they're more than enough. Okay.
Jump
So,
in, Rafael, because
yeah.
I think we didn't stress it enough. I didn't stress it enough in the first part. This is part of the intelligence of the system. This is injecting knowledge into the system and the data set. Knowledge that is in the background of any text we create. We know we have this knowledge, but computers don't. So we make it explicit, and it also helps out of these relationships, we help the system infer new knowledge. So these systems have knowledge that is inferable, not just explicit.
Exactly. This is what I wanted to say. This is what I said in the very first slides. Computers, we have some things in our mind, and I think this is a trap when you first build your ontologies, right? We always think that, okay, everything is easy for the system, but everything must be defined for the system. The system does not have any knowledge about what we want to build. Everything must be defined, and these characteristics help us give the intelligence, as Maria said, to the system. Okay? And thank you so much, Maria, for helping me in that. So let me move on. And here is a very nice slide also from Christophe. And here you can help me and let me summarize everything. The RDF graph is a directed label graph data format for representing information in the web in such a way so as to permit the automatic treatment of such descriptions. RDF graph is a knowledge graph using RDF as a representation knowledge. Can anyone help me in this graph? What is represented? Can anyone help me with that? Maybe I can. Portrait of Mona Lisa, wonderful. And maybe what pieces of information, what knowledge about Mona Lisa? Is there only Mona Lisa? So we have an object that has a title, Portrait de Mona Lisa.
There's also the creator.
Wonderful. The creator, which is an agent and has a label, Leonardo da Vinci or Leonardo da Vinci, etc. And has a subject that has a label, human.
Yes.
And a human being, and has a format, wood.
Yes.
Okay? And this is very interesting because I will show you that. This is what we do. This is the machine readable part, and this is the human readable, what we see in a website. Okay, and you can see in the left part what the properties, the terminology, the ontology, and in the right part the values of the properties. Okay, and here are some vocabularies. You saw some of these with Maria. We have RDF and RDF schema, resource description framework, the basic languages. We have the domain ontologies, Dublin core and friend of a friend, and the domain ontologies, COS and OWL. Okay, and let's try now to see more things about the theories of concept. What is a concept? Okay, the concept based on Oxford Dictionary is an abstract idea, a general notion. And based on Wikipedia, concepts are mental representations, abstract object or abilities that make up the fundamental building blocks of thoughts and beliefs. This is a very philosophical definition, isn't it? And based on the ISO 1087.1 standard, is a unit of knowledge created by a unique combination of characteristics. So what is a concept? Is a unit of knowledge created by a unique combination of characteristics. So what we have is we have something in our mind, let's say, that has some very specific characteristics, and this thing, we call it a concept. So the theories of concept, more or less, there are two. We have the concept that it is defined by their relationships, and this we call it a class, and we see it more in Protégé. And we have the concept which is defined by their essential characteristics. So in Protégé, when we want to define, for example, who is a Chinese person, okay, we are linking with some relations different individuals. And this is what we do to try to define in the classic expression editor, to define the relationships between, we define the classes between the relationships between the individuals, okay, and the classes. So in Protégé, we would say that a Chinese person, if we have, for example, a set of things, we would say that if we have an X, for example, which is a person, and you can see here, that is a person, a Chinese person is someone that it is linked to another set of individuals, which this set of individuals may be named countries, for example, and it is linked with the individual China. So if we want to define a Chinese person, we would say that it is an individual in a set of things, that it is linked to another set of things, that it is, they may be countries, and this thing, it will be China. And this will happen with a relationship named lives in or comes from. Okay, and this is the one part. We define everything through the relationships between the individuals. And the other part, the second theory, is to define everything through the essential characteristics. And I like this example very much with the clock because it is very easy to understand. So we have a timepiece. Okay, so when we are thinking about the timepiece, we are thinking about that, about something, an object that shows us what time is it, right? So we have a timepiece that we have timepieces that they are portable and they're non-portable. So when we have a timepiece generally and we add the essential characteristic portable, we get a new concept, portable timepiece. So this is a new concept because we have the essential characteristic portable, okay? And now we can add a new essential characteristic, pocket portable timepiece, that now we have a whole different concept because we have added a new essential characteristic, the pocket portable timepiece. Okay, so this is the second theory that we say that we define things based on their nature, based on their essential characteristics. So if we want to define the pocket portable timepiece, okay, we say that it is a timepiece and it is portable and it is pocket. Okay? But if we have this concept, pocket portable timepiece, if we remove, for example, the pocket essential characteristic, we cannot say that it is, finally, if we remove it, it is pocket portable timepiece, because we have removed the delimiting characteristic. Okay, we have removed the characteristic that it is used and helps us to distinguish a concept from other concepts. So we cannot say that the pocket portable timepiece is just a timepiece and portable, because it also, this is a different concept. Okay, this is, I understand that this is a whole new world. We just try to define everything by its nature, and we are trying to do that very, 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 very carefully. And this is logic, right? This is pure logic. Are there any questions so far before I summarize everything?
Again, to say, Rafael, while you take a sip, that we need logic. This is logic-based systems, first order logic to be more exact.
Yeah.
Okay, logic is a Greek discipline. I mean, it goes back to ancient Greece, but it is still used for artificial intelligence systems like Protégé and TEDI. Yeah, the idea is to build systems that can reason in a white box way, in a transparent way, explainable way.
Yeah, this is very crucial what Maria said. We don't want to build systems that they cannot be reasoned. We need systems that we have defined everything correctly, and logic, it is, I think, of course, this is why logic is used in artificial intelligence, right, Maria? Because it's the only way that we can very explicitly define everything, and everything can be clear. And this is what the logical mind provides us. Okay, and we can start summarizing. So we have the nature of the thing, okay, the essential characteristic of the thing that differentiates the very specific, its very specific nature, that it differentiates it from other things. And then, of course, we have other characteristics, descriptive characteristics. For example, if I have a pocket watch that it is red, its color it's red, this is just its description. It is still a pocket watch. And then we have, as we have already discussed, the relations between objects. Things are defined not according to their nature, but through relationships between them. For example, the Chinese example that we saw. And this is what we defined as a class, which is a set of objects verifying a same property, objects linked with the same property. Okay, and lastly, the concept, which is the unit of knowledge created by a unique combination of characteristics according to ISO, the definition that we saw earlier. And the last thing that we will see, it's the conceptual and the linguistic dimension. So it is very interesting and very important to understand how we distinguish the conceptual and the linguistic dimension. The conceptual dimension, it's a different thing. So as we saw, all the definitions about concept, for example, from Oxford, we saw that it is a mental representation, the concept. And the concept, according to ISO, it's, as we saw here, it's a unit of knowledge created by a unique combination of characteristics. So a term, it is nothing more, it is more or less a verbal designation of a concept. So what we are trying to say here, it is that when we have a concept, we are talking about a unique combination of essential characteristics. The term, or let's say the human readable and the human understandable definition is nothing more or less than the designation of the essential characteristics that we have for a concept. Okay, so you see here, we have the timepiece concept. And this, or we can see it here, pocket portable timepiece. This concept has some essential characteristics from its nature. It is a timepiece, that it is portable, and that it is a pocket. And we have the term pocket watch, which is its a verbal designation, okay? And I have put also this, that you can find it in the website of TEDI. The definition of a term is a paraphrase of the logical definition of the concept denoted by the term. So if we have, for example, the ontoterminology of seats, and we have the concept seat with feet for one person with back with arms, this concept has some essential characteristics. It has the essential characteristics seat with feet for one person with back with arms. And you see here that the designation is armchair, but the term is nothing, it's for us. We have defined that this armchair is the designation of this concept that is a unit of some essential characteristics. And the definition that you see here is seat for one person with arms, with back and feet. So this is what Christoph tries to say here, that the definition of the term armchair is a paraphrase of the logical definition that you see here in the essential characteristics of the concept denoted by the term. So we have a term that designates a concept and a definition that it is more or less a paraphrase of the logical definition. Okay, and here I've put it, yeah. So let's see what an ontoterminology is, so we can put everything in its place. An ontoterminology is a terminology whose conceptual system is a formal ontology. Based on the fact that we just discussed, that linguistic and conceptual dimensions do not match, ontoterminology makes explicit the double dimension of terminology, the conceptual and the linguistic. Ontoterminology preserves the linguistic diversity, taking into account multilingualism, and allows to standardize the domain knowledge. And this is about multilingualism. We will see that because the knowledge base that we will create in the second part will be created both in modern Greek, modern Greek, English and Chinese. Okay, and here I have put a very interesting visual. Where is my here? Okay, here. This is the semantic triangle, which is Christophe's diagram, which illustrates the relationship between the ontology, the structure, a representation of knowledge, and the language for specific purposes. It shows more or less that in the ontology, a concept is linked to an object, as you can see here, and which this object is linked to an identifier, while in the language for specific purposes, we have a signified idea that corresponds to a term and its practical application, which is praxis. Okay? And this is very interesting because the diagram more or less bridges the two by highlighting that concepts in ontology map to signified meanings in the language for specific purposes, and the identifiers in the ontology align with the terms in the language for specific purposes. So what was tried to represent here, and I recommend you to read this very interesting article that it is also available online, and you can find it in the Ontoterminology in the TEDI's website, emphasizes the interconnectedness of abstract concepts and their concrete expressions and application in specific languages and concepts. And you will understand more of this when we are trying to model everything in TEDI. So finally, and this is what I got this from the TEDI website, building ontoterminologies is a task which requires a dedicated software environment. It is very difficult to build an ontoterminology in Protégé. Very, very difficult. Maria, do you agree? I hope yes. And then we will use the TEDI.
Not only do I agree, everybody agrees.
Everybody
Even
agrees.
Lita, our colleague student who is visiting from Nanjing University, who is in ICT and he's an accomplished programmer, he says, Protégé is not intelligent enough for me, I will not use it. But okay, Protégé has a big community of developers, and this is a good thing.
Yeah. So the tool that we will use is TEDI for Ontoterminology Editor that provides a set of useful tools based on epistemological principles. TEDI allows to define the formal ontology and the set of terms in the different languages independently of each other. The different sets of terms are linked through the shared ontology, and it also allows object and proper names editing as well as export in different exchange formats: RDF, HTML, SCOS, JSON, CSV, etc. Okay, and this is the end of the part one. Okay. So are we all back? Can we start? Okay. So this is the part 2, and we will focus more on modeling knowledge in TEDI concerning biographical pieces of knowledge for ancient Greek and Chinese philosophers. Okay, while we will use TEDI. Okay, so when we start to model knowledge, it is very important to concern some questions and have something in our mind. So firstly, what do we want to model? So we have our domain of interest. We know more or less what we want to do, but it is very important from the very beginning to have in mind what we want to model. Okay, and it is also very interesting if you want to draw. I always love drawing when I start creating a model. Okay, and then we start defining our concept, our axis of analysis, our relations, our attributes, our objects. We will see more of this later. We start inserting terms, proper names, futures, etc. Okay, so what we will do today, we will create an ontoterminology entitled Ancient Greek and Chinese Philosophers, which will be developed in the context of this training, and it will focus on modeling ancient Greek and Chinese philosophers, their works, and their chronological and spatial distribution, which the last thing I think is very, very, very interesting. So this is a first model, an ontology level model of what we will do. So we have a philosopher who died in a specific at a specific time, okay, who was born in a specific time, who has a death place, if we know the death place, of course, who is an author of philosophical work, who is a student of a philosopher. There are so many things that you can model when you start creating a data set for philosophers, right? There are so many pieces of knowledge. But what I am trying to say is that it is very, very, very crucial and very important to start considering what do you want to model. And this is, I think this is the most difficult part, because you have to make decisions. Don't forget, of course, that you have to think when you define concepts in the way of first order logic. And of course, we were discussing that with Maria in the break. First order logic cannot describe and define everything. Okay, sometimes you are very oriented when you're talking in the context of the first order logic. Okay, but this is how we more or less work. And this is more or less a more extended graph of our ontology or our ontoterminology. Okay, so I have decided to orient this modeling process to just referring to ancient Greek and Chinese philosophers, okay, to say when they were born and when they died, to insert their death and birthplace if we know it, and also model one philosophical work for each. Okay, so let's start doing that together. Okay. So okay. So this is the folder that you got from Christophe, right? You should open that folder. If you are a user of Macintosh, you will open the TEDI IM file. If you are a user of Windows, you will open the TEDI exe. So, but what do we have here? And this is very interesting because Christophe provided you the whole folder, and this is very, very interesting and very useful. First of all, he has created a very nice and very short documentation, and that is why I didn't give you more things for that, because I strongly recommend you to see this very nice documentation that Christophe has created, and it is very brief, and it more or less summarizes what we discussed today about the theoretical part, okay? And this is the quick start, and also he has provided you with some more documentation, for example, a presentation that he has done, or some HTML that we will create too, and also with some OTBs. OTBs stands for Ontoterminology base. This is what we will create today. But Christophe, he has put already some 1, 2 criteria base and seed base. So if you want, you can see them later in more detail, because you can understand that in 1 hour we cannot create such complex base. We will create a very easy base. But these are more complex and more complete, so you can see them later, okay? So this is more or less what Christophe has provided you. So if you want, click on that, okay? TEDI-IM if you are a user of Macintosh, and TEDI-exe if you are a user of Windows. And this is what should open. Are we all there?
Yes.
Okay.
Software.
Okay. And you should put your password and your username, which is Teddy and Teddy. So here we are in the multilingual Ontoterminology editor. We are in the in TEDI, okay? So there are so many buttons in TEDI. It is very difficult to present everything, but I will do my best, I promise. So from here, you can load an OTB. From here, you can load, for example, the OTBs that Christophe has provided you. And you can load your, of course, OTB when you have everything saved. But now we want to create a new OTB, okay? So we click in the new OTB. Okay. Philosophers and NUAA. Okay, so now we have created a new file, a new OTB file that, of course, you can understand, it can have many ontoterminologies inside of it. So now we want to create our first ontoterminology, and we can name it Ancient Greek and Chinese philosophers. Okay? Are we all there?
Yes, I'm following just
Okay.
5 different names.
Okay. So we can also define the domain of knowledge of our knowledge. So for example, here in the domain, we can add humanities, in the subdomain philosophy, and in the other domains, ancient Greek and Chinese philosophy. And of course, you can add if you want a comment or the comment that I have provided you in the PDF file. Okay? The current Ontoterminology entitled, this comment is for the whole Ontoterminology. Okay? So let's start now with some more interesting things. Here we have the traces, list of perform instructions. So if you click, you can see everything that you changed and when you started editing or creating the Ontoterminology. And this is very important, as you can understand. Okay, from here, you can edit the languages that you will use for your Ontoterminology, because we have described already how important languages are in the defining and the modeling process. Okay, so okay, we have N, which is the ISO 639.1 language tag for English language. And we can create a new language for ZH, which is for the Chinese language. Are we all there?
Just added new language as Chinese.
Okay. So let's move on. And now we can start with the 2 dimensions, okay? So we have, as we have already discussed, the conceptual dimension and the linguistic dimension. We are talking about 2 different things. The conceptual dimension, as we have discussed, the concept is the unit of knowledge with that it is defined with the essential characteristics. Okay, so we can start by defining our concepts. Okay, so you can click on the concept editor. And please do not have a heart attack. This is what I had when I first saw the concept editor. Okay? Are we all there?
I open the concept editor.
From here, conceptual dimension, concept editor. Okay? And we can start by defining our concepts, our main ideas of our Ontoterminology. So, what we want to model? We want to model philosophers. Okay? Philosopher. This is our first concept. And of course, we can create sub-concept of philosopher. So we can create an ancient Greek philosopher and ancient Chinese philosopher. As you have understood, here we create a whole new category, a whole new concept. The next button here is a new sub-concept. So if I want to create a sub-concept of philosopher, I may click in the philosopher concept and click the second button. From here, I can create a new sibling concept, sorry. For example, if I want to create the ancient Greek philosopher and I only have ancient Chinese, I may click here, okay? And from here, I can create a new concept again or delete a concept, okay? And I can also do that from here, from the new from the, I can delete or rename. Okay, are we all there?
When we create the new sub-concept,
Mm-hmm.
when we type the names, do we
Mm-hmm.
have to connect different words with that little, a little underscore, a little underline?
Yes, that would be good.
Okay.
But I think the system does this on its own. I don't remember, to be honest.
Is it
But
necessary?
it's not that
Okay.
important. Yeah, it's not that important at the moment.
Okay, so I can just type the names.
Yeah, yeah,
Spaces between the words,
yeah,
right?
exactly.
Okay.
Okay, and then we can also start defining location, because as we said, we want also to have the spatial, let's say, information of our philosophers, where they were born, where did they die. Okay, so location, and also we can put ancient Greek location and ancient Chinese location. And lastly, we also mentioned that we want to model a philosophical work. So we can create a philosophical work concept. Are we all there?
Yes, I added 2 more concepts.
Okay. So can any of you tell me how can we differentiate the sub-concept of the sub-concept of location? What is, and what I want to say is, what is the essential characteristic that differentiates the location from ancient Chinese location and from ancient Greek location? We have the concept location. What is the essential characteristic in its sub-concepts that help us differentiate from its mother concept and from its sibling concept? Can anyone help me with that?
Location has to be a place.
Yeah, a place, yeah. But what differentiates location from ancient Chinese location or ancient Greek location?
What difference?
Or what is different between ancient Chinese location and ancient Greek location?
Well, there are different locations.
There are different locations. What is different?
The geographical location is different.
So we are talking about different origins. We are talking about different places. So we have location, we are talking about places, but from the one hand, we are talking about ancient Chinese, and in the other hand, we are talking about ancient Greek, right? This is what differentiates ancient Chinese location from ancient Greek location, and both from its mother concept, right?
Yes.
And it's the same if we see all the other sub-concepts of the other mother concepts. So we have philosopher, and we have ancient Chinese philosopher, and then ancient Greek philosopher. And then we have the philosophical work, we have ancient Chinese philosophical work, and then ancient Greek philosophical work, right? So everything is differentiated based on their origin, based on their place in earth and time, because we are talking about Chinese and we are talking also about ancient Chinese. So the essential characteristic of the sub-concepts of location, philosopher, and philosophical work is ancient Greek and ancient Chinese, right? So now we have started understanding how the axis of analysis works. The axis editor helps us define the essential characteristics that we are discussing all this in the previous session. So we can define a category, a general category axis, just to put all the first concepts, location, philosopher, and philosophical work, and then we can create a new axis named origin. So we can put in all the categories the essential characteristic of the origin, if it's ancient Greek or ancient Chinese. Okay, are we all there?
Where do we find the axis of analysis editor? Where do
Yeah,
we
a
this?
very good question. In the conceptual dimension, we are in the conceptual dimension. We are not talking about terms, we are talking about modeling. Okay, we are modeling now the concepts, the theoretical part or the conceptual part of the ontology, of the ontoterminology. So we click on the concept of, we click on the concept, the conceptual dimension here, and we click on the axis editor.
Okay, I see. Mhm.
And we create two axes of analysis, one here, new category for location, philosopher, and philosophical work, and one origin for ancient Chinese and ancient Greek. Are we all there? Luisa, now you will become an expert for all the tools. After the TOEFL training for SPARQL and Protégé, now you will become an expert also for TEDI. So you are...
Yeah, I hope so. Also learning from
So are we all there? Have we created our axis of analysis?
When I add a new axis, we should input the national identifier name, which, as you shown
No,
here,
you may put only the first, and it will do it automatically. Just do that. Just put category, for example, and add accept.
Okay, so I don't need to input anything in the international identifier name.
No.
Okay.
And in the difference, we add 3: location, philosopher, and philosophical work. And then we create the origin, ancient Chinese, and ancient Greek.
When I add a new difference, when I click the new, is there anything I should input?
Yeah, in the national identifier name, type ancient Chinese in the difference. Erase that and type ancient Chinese and ancient Greek. If you are, of course, in the origin. If you are in the category, you type this: location, philosopher, and philosophical work.
Oh, okay. Do I need to separate the 3 words with any symbol on anything?
You create 3 differences. So one difference is location, accept, and then philosopher, accept, and then philosophical work, accept.
I see.
Yeah,
Right.
because there are 3 different essential characteristics, one for each category.
Okay.
So are we all there? Okay, and now that we have defined our axis of analysis, we may add them to our concepts. So here in the location, we have our editing environment here. We have comment, we have generic concept, inherited and known differences, inherited and known attributes, relations, formal definition, and here is the term editor. So if you go there, inherited and own differences, and in the add part, you select the category and location. Accept. You go to the philosopher, you go category, philosopher, accept. And in the philosophical work, category, philosophical work, accept. And now you have put the essential characteristics of the categories, of the generic concepts. And if you go, and this is very interesting for you to understand, if you go, for example, to the ancient Chinese location, you will see inherited differences, location. Why? Because it is a sub-concept of the location, but we need an essential characteristic so we can differentiate the ancient Chinese location from its mother concept, which is location. And how we can do that? That is why we have defined the origin. And we type ancient Chinese here and ancient Greek here. So now you see here we have a red message, a red warning, no own differences. But if we add origin, ancient Greek, it disappears. So now our system is more consistent based on that. And we may do that to all the other concepts that we have defined. Ancient Chinese, ancient Greek, philosopher, ancient Chinese philosophical work, we add the ancient Chinese axis of analysis of the origin. Are we all there? And from here, in the formal definition, you can see what we were discussing earlier. We have what is an ancient Greek philosophical work. It's a philosophical work because this is its mother concept. And then we have the axis of analysis origin, which we chose the ancient Greek difference. Essential characteristic. Okay. And this is more or less what the axis of analysis editor does. So we define the essential characteristics. Now we may move on to the relation editor. In the relation editor, we can define what we were discussing earlier with the relationships. So we have what we want to refer, what we want to model based on the knowledge that we were discussing. We want to define the birthplace of its philosopher. So a philosopher has a birthplace. Okay, has birthplace. Can anyone tell me what is the has birthplace inverse relation? So we have now a philosopher has birthplace location. The inverse location philosopher. Can anyone help me with that? What is its inverse relation? First of all, are we all together in the relation editor? Maybe I should wait. So I repeat, we are here and we click in the conceptual dimension. It's here. In the conceptual dimension, and we click in the relation editor. And are we all here? I also check the chat. So if you have a problem with that. Okay, so its inverse property has birthplace. It is birthplace of. And it is very important to define the domain and the range of each relation, as we have already said. So the domain node of the is birthplace of property relation is the location. So here in the domain, we click on add a concept and we choose location. And in the range, we do the same. Add a concept. We click here in the select concept, philosopher. So in this way, we say that a location is a birthplace of a philosopher. And we can do that in the has birthplace. Add the concept. Now we have its inverse property. So a philosopher has birthplace, a location. Okay. Okay, thank you so much, Maggie. Thank you so much. And if you have any questions, don't hesitate to mail me. You have my mail. Okay, are we all there? Have we defined the domain and the range of our has birthplace and is birthplace of relation? Okay.
I think for the students, maybe the first time is always a little.
Sorry, my dear, I didn't hear you.
I mean, for students who learn this for the first time, maybe it's always a little difficult.
Yeah, I understand, of course. Of course, take your time, it's not problem.
Yeah, they can watch the recording later. Yeah, several times.
Okay.
Until they
Okay. So now that we have defined the domain and the range of these two relations, we can select its inverse relation. So we know in our mind that has birthplace and is birthplace of are inverse properties, but we have to define this also to the system. So here we have the inverse relation button, and we select, and we see here that there is birthplace of. We can see it here. So we click the select, and we know that the has birthplace, its inverse relation is birthplace of. And automatically in the is birthplace of relation, its inverse is has birthplace. Okay? And now we can move on and define some other relationships, like has death place and is death place of, and is death place of, we put location is death place of a philosopher, as we did in the birthplace, okay? And in has death place, a philosopher has death place, a location. Okay, and now we are in the has death place relation, and we can select an inverse relation, which is the death place, is the death place. And if we go in is death place of, we have the inverse relation has death place. Okay. And now we can define the last four. For example, has written for the philosophical works, and its inverse is written by. So is written by, a philosophical work is written by a philosopher, and a philosopher has written a philosophical work. And we may select the inverse property, which is written by, in the has written. And if you go in the is written by, its inverse relation is has written. And this is a very good thing. TEDI does many things automatically. Protégé does not do many things automatically. So TEDI helps us a lot with these things. Okay? And the last relation that we will define is the is student of and is teacher of. Okay, so is teacher of a philosopher is teacher of another philosopher. And is student of a philosopher is a student of another philosopher. And in the inverse relation, we can we can define that. So these are more or less the relations that we will work with today. So now we have defined our relations. So if we want to start modeling at the moment, we lastly need to define our attributes. Attributes are a kind of relations, but not between nodes. Attributes are more or less relations that start with a node, that it may be a concept or an object, but links to a value. And I more or less use it here for the born-in relation and the died-in relation. So for the when someone was born and when someone died, okay? But we still need to define the domain. Who was born? Who died? The system does not know these things until we specify the domain. So in the domain, we go and define the concept. We add the concept, philosopher. And in the died-in, the same, philosopher. Okay? And born in, we may say that our value, it's a date, or died in, it's a date. Okay? So now we have defined our attributes and our relations. But what we should do firstly is to place them in our concepts, to say that we want to use these attributes and these relations. So if we return here to the concept editor and to see the location, here in the inherited and known attributes, we don't have anything because we do not have specified any attributes for the location concept. But in the relations, as you see here, we have two available. So we add the is birthplace of and the is deathplace of. Okay? And now, because these are defined in the location concept, they will also be inherited to the ancient Chinese and ancient Greek location. So we can do that also to the philosophical work with the is written by relationship. And we can finally go to the philosopher concept and add all our relations that we want to model for the philosophers. The has birthplace, the has death place, the has written, the is student of, and the is student of, the is teacher of. And here in the inherited attributes, we may add the born in and the died in. So this is how we say that for the objects that they belong to this concept, we want to say that we want to use when we model the objects of these concepts, that we want to use these relations. Okay? So now we can move on and see some things in the term, the linguistic dimension. So we may start to define the term editor. We don't have so much time, so we will do the English part, and you can do at home the Chinese part. Okay? So we can define, oops. Okay. Sorry for that. Don't know why it terminated. Okay. Okay. So now that we are here, we can define in our term editor the terms that will designate in the English language the concepts. So we have location, ancient Greek location, and Chinese location, ancient Chinese location. Don't forget in the term editor to change the status to preferred. So we have preferred, preferred, and preferred. And here in the ancient Chinese location, we can update the denoted concept to say that my ancient Chinese location term designates the ancient Chinese location. Select. The ancient Greek location designates the ancient Greek location. And my location designates the location concept. And then we can move on to the philosopher, status preferred, update philosopher, ancient Greek philosopher, that it is preferred, and I may update here to the ancient Greek philosopher, and ancient Chinese philosopher. That designates the ancient Chinese here, and it is preferred. And lastly, we have philosophical work. That it is preferred and designates the concept philosophical work. And then we have ancient Greek philosophical work. And lastly, ancient Chinese philosophical work. Date, ancient Chinese philosophical work, and preferred. And now we have designated all of our concepts with English terms, okay? So if you now go to the concept editor and click on the labeled option here, you can see our terms. Yeah, ancient Greek. Yeah, it was not preferred, okay. So here we are. We have defined all of our terms in our concepts. And now we can start by modeling our philosophers. So the philosophers, of course, are objects, are individuals, as we call them in Protégé. So in the object editor, we may start defining our individuals of the concepts. Okay, so now you have a PDF file that has some material for each philosopher. So we may start with Plato. So Plato is a philosopher, okay? So we insert a new object and we say that it is an instance of a concept. But for which concept it is an instance? It is an instance of an ancient Greek philosopher. Okay? And now we can say here, okay, for Plato. And you can see here the keywords that refer to what we want to model. So Plato was born in 428 to 23 BC and died in 347 in Athens. So now we have another object. We have Athens, that it is an instance of the ancient Greek location object, concept, sorry, ancient Greek location object. And he has a teacher, Socrates. Socrates is another philosopher. Socrates, who was also an ancient Greek philosopher. Okay? And he has a student, Aristotle, who Aristotle, as we see, he is also an ancient Greek philosopher. Okay? So, and then we have the most famous pieces of philosophical works, it's Republic and Phaedrus. So, or a Symposium, of course, there are many. So, we may use Republic. And here, in the instance of concept, we say ancient Greek philosophical work. Okay? Are we all there? This is the most interesting part, I think. All right. So, and always do not forget to save your work. You can go back here in the multilingual Ontoterminology editor and save your work here in the disk. Okay, so here we have started populating our Ontoterminology with objects, okay, and with instances of concepts. All right, so we have defined Aristotle, Athens, Plato, Republic, and Socrates. Okay. So now we may move on to defining some more objects. Or we can do something else first. So if you're in the object editor here and you double click in an individual like Plato, you will have this TEDI external link editor. And this is also very, very interesting if you want, for example, to add pictures. So if you click here in the add external link, and you click on the fourth depiction, which the fourth depiction is from the vocabulary that Maria presented to you, the friend of a friend vocabulary, you can copy the depiction that I have put you in the material and enter, copy paste it here. And this is very interesting afterwards when we will see the HTML export, the dictionary. And of course, you can add some others like RDFSC also, which is used to add some more like see also sites. And I have more or less, I try to put here from Baidu Encyclopedia, and you can copy paste them here. Just never forget to enter valid URLs or URIs. Don't put empty spaces or something like that, because you will get errors later. Okay. Luisa, do you think that we should have a 5-minute break now? Because I think I have said many things. What do you think?
I think so. So maybe have 5 minutes break.
Okay.
Or maybe 10 minutes. Maybe the students can try software by themselves.
Mm-hmm. Okay, let's have a 5-minute break and we will be back, okay?
Okay, no problem. Yeah.
I cannot hear.
No problem.
Okay. Sorry, I cannot hear you that well. Okay, and we will be back. Okay. So we now may move on again to the object editor to link the different objects that we have created. So we know that Plato has birthplace, according to our knowledge here, has birthplace and death place in Athens. So in the has birthplace, here in the object editor, we have all the attributes and relations that we have added in the concept editor for each concept. Now for each object, we have every relation that it is available in its concept. So Plato is instance of concept ancient Greek philosopher. And because the ancient Greek philosopher, it's a sub-concept of, oops, sorry for that. Okay. And because the Plato is an instance of an ancient Greek philosopher, and thus ancient Greek philosopher is a sub-concept of the philosopher concept, that we have added these objects, these relations here. Now we have them also in the object editor in Plato. So we may say that Plato has birthplace Athens, has death place Athens, has written Republic, is student of Socrates, and is teacher of Aristotle. Okay, and he was born in born in 422, 428 to 23, we are not sure, BCE, and he died in 348-47 BCE. And this is how we model an ancient Greek philosopher. And now we can go, so we have everything settled in the proper name editor and define our proper names. So we have the objects, but we need a term for this object, a linguistic dimension of these objects are called proper names. So we have Aristotle, denoted object Aristotle, Plato, add Plato, Athens, add Athens, Socrates, and lastly, Republic. Okay? So also here we may add comments or notes. And I have actually done this thing, and you can see more things about that in the Ontoterminology that I have sent you. But you may, if you want, put comments here, like he was born there, he described all these things. And also you can add notes. For example, here you can create a note and put a quote of him here in the notes. Okay, and now we can model also Confucius, and then we will see the exports, which are very interesting in my opinion. So Confucius is an instance of an ancient Chinese philosopher, right? So he was born in 551 before Common Era. I prefer before Common Era than before Christ. And he died in 479 before Common Era. He was born in, sorry, Luisa, can you tell me how it is correctly pronounced? Khufu or How it is?
I think it's Confucius. Confucius, or in Chinese, you can call him Kongzi.
Okay, and it's this location, Qifu, how it is called, how it's pronounced?
You mean Aristotle?
Sorry?
You mean Aristotle, right?
Here.
Okay, it's Analytics.
Okay, okay.
No, it's like something like Tufu, Luisa, the birthplace of Confucius.
Sorry, Tufu. Yes, it's
Qifu, okay. Okay, thank you.
You're
I'm worrying, I'm sorry, I don't, my Chinese are horrible. You should teach me Chinese when you come to Crete. We will do that, definitely. And Maria and Christophe, French. We will do that. So, Khufu is birthplace of Confucius, okay? And he has birthplace here, and we can select that. Also, he has written, as we know, Analects, and it's an ancient Chinese philosophical work that is written by here in the relations by Confucius. Okay. And we may also add a depiction for him. Here, or of course in RDFSC also. Okay. So this was a very small sample of how we are trying to model the philosophers. And now the more interesting part, in my opinion, is the exports that TEDI has available. And now what we can do, and please do that, all of you, for me, I have provided you an OTB. I have sent, Luisa, I have sent in the folder that I've given you, it's an OTB file. Okay, so please open that. You go here in the load OTB. Please do that with me. Load OTB. Do you want to exit of the current OTB? Yes. And try to find the OTB that I have sent you. Are we all there? You load the OTB that I sent you in the material. So firstly, the different exports that we have is my favorite one, the HTML dictionary, and which I have already sent it to you but yeah, we can do it together. Like you press here, export HTML, and now we will export the proper name dictionary. So we want to see what we have done with the philosophers, with the object, not with the concepts. Proper name dictionary in English, and I want to see everything. So all, I save it, and I have my export done. Okay, have we done? Are we done with that? And you may open it. Here it is. So the HTML export of TEDI has, it is a very beautiful dictionary actually. So, and you can see what we have in the HTML for each philosopher. So you can see here, for example, Aristotle, we have, we did together Plato. You see the depiction of Plato here. You see that we have added that he is an ancient Greek philosopher, the comment that we added together, the quote that we added together, and here are the pieces of information that we modeled. He died in 348 or 47. He was born in this span, is student of Socrates. He has written Republic, is teacher of Aristotle, has death place Athens, has birthplace Athens. His depiction is here. You see that TEDI does this very beautiful thing. If it's a JPEG or a PNG URL, it takes the picture and you have it here. And we have also added the RDFS also links. Okay, and here is Confucius. So he's an ancient Chinese philosopher. We have a comment, a note that it is a quote of his. And yeah, this is very interesting. The equivalence, the term equivalence, the proper name equivalence, which is here in the Chinese, and it was also here in Plato. Okay, so here, when did he die, when he was born, what he has written, his death and birthplace, the depiction of his, and the some links that we have added with the RDFSC also. Okay, so this is the first export option that we have. This is the HTML export. The second option that we have is the RDF option. The RDF, as you have understood these days, it works and it opens in Protégé. It's the language of the ontologies. So if you have Protégé, and of course I haven't asked you to download Protégé, it is not needed in my opinion for this course. What you can definitely do is open with here, for example, with a text, where is it? Text edit app. And you will see here, it's the RDF, the OWL file. You see here what we have done all together in the RDF file. But if you have, of course, Protégé, this will be more helpful. And this is the Protégé environment. You see that TEDI transfers everything and turns everything in RDF, so we can edit it also in Protégé. You see the title of our ontology here, Ancient Greek and Chinese philosophers, the description, the publisher, the creator, when it was issued and modified. You can see here the entities, and maybe we can see here is Confucius, and you see how everything is modeled in Protégé and how TEDI has placed everything for us in Protégé and we didn't have to do anything. So this is the second export of TEDI. And because I like visualizations, you can also try maybe later this app that allows you to import, to add an RDF file and see its visualization. So we can do that. Okay. And here is our RDF file visualized. So here, now here you see concept, ancient Greek philosopher. Here you see philosopher, is student of, the relationship, the attributes, born in, died in, born in, is student of, is teacher of, has the location, has coordinates. Unfortunately, we didn't have time to see that, but you have the OTB, so you can explore the OTB. You have the description here. And also here in the language part, you can change and see the Chinese, because I have put also the Chinese terms here. And this is very interesting. And lastly, the last export is the CSV map, where you can see the CSV files, the comma separated value, okay? So, and you can, okay, let me just put that here. You can import this, this CSV map to the Semap tools tool, which will help you draw a first diagram and will help you in the first visualization of this thing, or by importing the comma separated value. So you can put here file, import, proposition as text. Here. And you have a first graph of the hierarchy of your concepts. Okay? Right. All right. So this was more or less what TEDI does. I think it was very brave of you to see the whole TEDI in and we are just on time. I wasn't. I think I didn't got some more time of your precious time. So thank you so much for your attention and patience. You have everything. I've provided you with the RDF, with the OTB. I've given you everything. Christoph's documentation for TEDI, it's very, very precious and very, very interesting, and it really helps you a lot. I am available on whatever you need. Just send me an email. Do not hesitate to do that. And of course, as Maria said, we are very, very open to having new colleagues in this amazing data set. Philosophy is very beautiful, and building a data set for philosophers is more beautiful than working with philosophers. Thank you so much for your attention and patience. And really, we have, I think, 2 or more minutes to hear questions or comments or your thoughts, whatever you want. Thank you so much.